Vibration analysis. Procedures for accurate evaluation of machinery condition. Special tests. Relative motion measurements or RMM. It is beyond the scope of this book to give an example of every case where relative motion should be measured. However, it is important to emphasize the need and general application of relative motion measurements. A relative motion measurement measures how much one part is moving relative to another part. The measurement is normally made in thousandths of an inch or mils. This is not a new measurement technique. It has been used for years with an instrument called the dial indicator. We now have electronic dial indicators called displacement transducers. These transducers can be of the contacting type or the non-contacting type. The contacting type, or linear variable differential transformer (LVDT), has been used for years in the gauging industry. The non-contacting type, or proximity probe, has been used for years in the turbo machinery industry to measure relative shaft motion in fluid film bearings. The use of these instruments in both applications has been quite successful. Portable variations of these transducers have been used for years to accurately diagnose problems in rotating machines. The major advantages of these transducers over the dial indicator are: Number 1, the output can be processed on an RTA to obtain a time signal and frequency spectrum. Number 2, they can be used while the machine is in operation, often without adversely affecting the operation. And number 3, they can be used to diagnose defects in anti-friction bearings on shafts rotating less than 1 RPM. Refer to the for example in the next chapter of this vibration analysis video talking about procedures accurate diagnosis of anti-friction bearings. Number 4, they are required to diagnose gear problems in slow-speed machinery when the gear and shaft weigh less than about 10% of the housing weight. Refer to the for example in the next chapter of this vibration analysis video talking about procedures accurate evaluation of gears. Number 5, they are required to measure the roundness of operating steel rolls. Refer to the last chapter of these vibration analysis videos, analyzing and solving press roll and nip problems for examples. Number 6, they are required to measure the amount of looseness in a bearing, the bend in a shaft, and the amount of misalignment in a coupled machine. Number 7, they are required to measure the relative motion measured between two beams or structures before bracing is attempted. The data in Figure 54 shows the relative motion measured between a turbine and the coupling. The spectral line at 35 Hz is 2 times fan speed and is caused by a problem in the fan. 3 mils at 35 Hz equals about 0.36 inch per second of velocity. The spectral line at 72.5 Hz is turbine speed. 6 mils at 72.5 Hz is about 1.4 inch per second of velocity. These vibration levels are excessive, and the data indicates a problem in the fan and misalignment between the turbine and gearbox. The data in Figure 55 shows the relative motion measured between a motor housing and the shaft. The spectral line at 7.5 Hz is motor speed and indicates imbalance. 12 mils at 7.5 Hz is equal to about 0.24 inch per second of velocity. Since more than one problem can generate the same frequency, relative motion measurements are often required to accurately identify the problem and distinguish between imbalance, looseness, bent shaft, etc. In conclusion, the technology presented in this chapter should be helpful in accurate diagnosis of machinery problems. There are many quick fix principles and schemes available for machinery diagnostics, and most, if not all, have some merit. However, people in the vibration analysis field have a responsibility to achieve as much accuracy as possible. Thank you.